A'udhu billahi minash shaitanir rajeem. Bismillahir Rahmanir Rahim. Starting with the great name of Allah, who is the most beneficent and most merciful. First of all, I introduce myself. My name is Daniyal Abbasi. My registration number is 2021-16. Our assigned task is related to load flow analysis project. This project is related to the subject mine power drainage and material handling lab. This project is submitted to Dr. Muhammad Zakka Imar. Our problem statement is to determine the load flow analysis of the mining engineering department at UT Lahore. Calculations must be done manually and simulation must be performed using any software. Afterwards, both sets of results should be compared. Then, first question arises in our mind: what is load flow analysis? Load flow analysis is a method used to calculate and analyze the flow of electrical power in a network. It is also known as power flow analysis. This picture showing the little bit sketch of load flow analysis of our project. Then types of power. There are three types of power: active power, reactive power, apparent power. Actually doing the work is active power kW, kilowatts, does not perform actually work. Then its reactive power, total power present in the circuit is apparent power, that in kVA. I need this power for the calculations. Then you can see the power triangles: apparent power, active power, reactive power, and this is the impedance angle. This formula is used to calculate any missing power. Then power factor, it is the ratio of active power with the apparent power. If apparent power is greater than the active power, then power factor is less than 1 and reactive power greater than 0. How I start the project? Start by recording the quantities of items like bulbs, LEDs, fans, and machines in the mining engineering department. Input this data into an Excel sheet by applying formulas and calculate the total power consumption in watts. Add the power factor of each equipment and multiply it with the active power in kilowatts to find the apparent power in kVA, kilovoltage ampere. Repeat these steps for the items that are present in our project. I put some screenshots from the report into the PowerPoint. Then I add some headings: equipment, quantity, power for 1, total power, power factor, apparent power, working hours, energy. For example, first is ceiling fan. Quantity 1, power for one fan is 55. Then multiplying with the quantity with the power factor, find total power. And then adding power factor, then total power divided with the power factor, then we find apparent power. Then apparent power is the working hours to find the energy consumptions. Same as first year row. I divided the total power into two sections: total power of ground floor, total power of first floor. I add some all the offices, labs, library, like other stuff, all other stuffs, etc. That are present in ground floor and the first floor, which I am putting this into the lab report. Then total power calculated: active power, apparent power, reactive power. I need this power. Ground floor power 73 kVA, first floor power 25 kVA, then total power 98 kVA. It's mean I need 98 kVA power for mining engineering department. Then solution. The mining engineering department at UT Lahore requires a 100 kVA generator. It's important to note the installation location for this generator is outside the department building itself. Ideally, the transformer would also be situated outside the mining engineering department building. Then you can see the 100 kVA transformers. After this software simulation, I use ETAP software. So what is ETAP software? ETAP software is a powerful tool used for by the electrical engineer for designing, simulating, operating, and optimizing the power systems. Its application is load flow analysis, short circuit analysis. So that's why I use ETAP software. I followed this procedure. Open the ETAP software, choose the power grid station, add buses to the grid, add cables to connect the buses, add transformers to the grid, add lump loads to represent the power consumption in different sections, input the relevant data for our projects such as rating of transformer length and sizes and cables and the power values for lump loads, simulate the grid to analyze the load distribution of the parameters. Buses are the junction points to connect the different electrical components such as generator or load. And lump loads is both static and motorized load. This picture is showing the software simulation results. Then it's power grid, then buses, then cables, then transformer, then buses. Then it can be divided into 4 sections. Section 1, lump load 1, lump load 2, lump load 3, lump load 4. And then this is showing the active power and reactive power. Reactive power, and kV, kilowatts. Then same screenshot, but unit are changed. Then kVA and ampere. Then showing the kilovoltage and ampere. Then showing the kVA, actually apparent power and amperes. This is a circuit diagram of load flow analysis of mining engineering department. This red area shows the software simulation results. This red area shows the software simulation results of mining engineering department. This red area especially shows this circuit is under voltage. Okay, and then comparison. Manual calculations require separate computation of active power kilowatt, apparent kVA, and reactive power kVA, along with other parameters like voltages, amperes, and impedance angles. Then ETAP software automatically calculates all types of power, voltages, amperes, impedance angles, and losses when data is inputted. In ETAP, you can create a circuit diagram and distribute the load to different sections. Lump loads are collected at the end of the buses in ETAP. ETAP provides a more efficient and accurate analysis as compared to manual calculations, which can be time consuming and prone to errors. These are the comparisons between the manual calculations and the simulation results of ETAP software. Thank you for listening.